Hi, Electric Guru here. Welcome back. Today I wanted to talk about a Dynaco SCA-35 vacuum tube amplifier that I rescued from the trash pile. If you watched any of my previous videos, I did one that I mentioned where I drug home a bunch of old radios for restoration, and this amplifier happened to be in the bunch of them that I had pulled out. I did a lot of modifications to it, but before I go on, I want to mention all the modifications that I did were because of the hard work that Dave Gillispie has put into this amplifier to make all these improvements. So if you happen to be over at Audio Karma, give Dave a heads up and a thanks for all the hard work that he has put into this. So here's the front panel. I have a lot of photos because I did this over a long period of time, so I didn't do any actual videos of it. But this is what it looks like from the front after I had done the work. And I have the top cover off and the bottom of the chassis just for these pictures. But the front panel cleaned up, not too bad. I replaced all the knobs. I found replacements. I had to replace those. They were pretty corroded. And also I replaced all the switches on the front. And let's take a look at the back panel here first. Now I replaced all the input jacks, and I actually replaced the speaker jacks. Now I don't like those screw connectors, but these ones were pretty corroded. But if you see what I put, then these work out pretty nice. They take a 2mm jack, which I've used these before on a couple other things, and they're pretty nice. They're solid, and that was the only thing I could find that would fit in place of the screw connectors. But these worked out pretty good. You can buy better ones, fancier ones, but these are the plain Jane, and they'll work for me for now till I pick up some better ones. Also, the power connector, I wanted a 3-prong connector in there, and I use these Nutric connectors on a number of my amplifiers. They're pretty nice, and they lock in there. They're pretty solid. But this one, to get it to fit, I actually had to cut it down a little bit so there would be space where it would fit in the back between that space and the chassis. And also, because of the wiring changes to the filament, you see the hum controls have changed a little bit, but that worked out pretty good. So let's look at the inside and from the top view down here. You can see in the back, I built out Dave Gillespie's EFB circuit, his bias circuit, on a turret board. What I did was I took the board and I put the turrets in from the bottom up, mounted the components on top, ran all the wires out from the bottom, and also made a turret board replacement that went in from underneath to hold the new capacitors. You can see that, and plus I put a hole in the part of the one board there by those capacitors where all the wiring goes down through from his Dave's bias circuit. And actually it worked out pretty good, and I was really surprised. The tubes in this amplifier are the original Dynaco branded. I'm not sure who made them, but the original branded tubes and the output, and they actually balance out pretty good with the bias circuit, and they're still working, so there's something to say for those old tubes. Now, I imagine what happened to this amplifier is someone had been using it, and I noticed when I got it, the selector switch had had a chicken head knob in it. So somebody must have lost the knob, knob, and they stuck that on. But what probably happened is one of the 7199 tubes had filled, the filament went, and at that point somebody probably just trashed it, I imagine. But also, in here I want to talk about the selector switch and how I took it apart and I cleaned it up because it was in pretty bad shape. But looking down in the front panel, I kept those original little modules there with the capacitors and the network capacitor and the resistor networks in them, because they checked out pretty good. They measured all okay when I took them off. So I kept those in there, changed the capacitors, as you can see, and also cleaned everything up, cleaned all those old controls on that front panel. And looking underneath here, you can see this is the end result. I completely, totally rewired it. And you can see the bottom of the board that I made for the capacitors. Again, I just used turret lugs and soldered those capacitors in from the top. And so that worked out pretty well. Now I wanted to use something different than the 7199s in there, so I wanted to put the 6GH8s in there. So I procured some new boards. Now these are from a board house. They're not Dave's boards because he does sell replacements, but you can see they're very similar to the original. They look the same, except the sockets are arranged for the 6GH8. And of course, I had to make the circuit changes that Dave recommended to be able to properly have good results with those 6GH8A tubes in there driving the power section. And I did have one crazy thing happen to me. Before I put the preamp section board in, I figured I'd fire it up just to make sure everything worked and make sure the feedback circuit that I laid out on the board, the bias circuit that I laid out on that board, make sure it worked. And on the left channel, I had motorboating. I says, what in the world? You know, when you have motorboating, it usually comes because you had the plate connections reversed on the output transformer. But I racked my brain over this for a while trying to figure out something that I did, and it really wasn't my fault. I checked everything over. I disconnected the feedback wire, and I still was getting motorboating. And I poured over that thing. What did I do wrong? What did I do wrong? And here, I didn't notice, but if you look on the left channel board, you will see a different resistor in there. When the boards came, that was supposed to be, I think it's R33 in the schematic, is supposed to have a 120,000 ohm resistor in it. What was 26,000? So the joke was on me. So replacing that, fired it up, and the tubes balanced out pretty good. I was surprised, for as old as they are. I still got that 27 millivolt, 0.27 millivolt average if you go by how Dave tells to adjust the bias board. It worked out pretty good. Let's see, some other things. Oh, you can see, here's a shot of, you can see down in there what I did on the inside of the back panel there. A little bit of close-up, you can see the wiring. And most all that wiring is new. Everything I changed, like I said, I gutted it. I left the auxiliary outlets, the two-prong. I just didn't connect them. I'll never use them. So, is what it is. And I left all the other connections. The only thing I have left to do is I can do a little better with the hum on a preamp section, the phono section. There's some more things that Dave suggests that I'm going to try to completely eliminate that hum. But I want to talk about the some of the circuit changes, and I just drew up a partial schematic highlighting some of the things that you would need to do if you make these modifications. And even if you're using an original board, the original Dynaco boards, and you get one of those adapters for the 6GH8, if you plan on using them, you need to make some resistor changes in there so that it's more stable than what Dave recommended. But first of all, let's look at the close-up on some of the schematics, some of the things here. Everything in red on this diagram is what I had changed. And if you look what's a square box in a red there at the driver tubes, you'll see there's a 100K resistor and an 18 picofarad, whatever you want to call it, capacitor going from the grid connection to ground. Now, if you viewed my article on feedback, and I left a lot of information in there, and an article from Tim Smith that I talked about, and he talked about adding snubbers to prevent high frequencies and oscillation in the circuits. And that's what I believe that Dave did here with that 100K resistor and that capacitor in series. So normally I would have to go in and make adjustments and look at the scope and do some different values, a little bit of math. But thanks to Dave, he did all the hard work. Don't have to. He figured all this out for us. And so looking at the grid connections on the output tubes, you'll see added 10K resistor where the original Dynaco design, they didn't have any resistors in there. Normally you'd throw 1,000 ohm in there, but it helps. It helps, but because of the 6GHH tubes for stability, they found that 10,000 ohms worked well. And also on the screen grid connections, there is a added 100 ohm resistor. Now I always put resistors on my screen grids again. Well, you figure Dynaco, they wanted to get it working best way they could with the least amount of components, because they add up, especially when a lot of guys change that single cathode resistor and will put 2 cathode resistors and capacitors in there. But you have to figure what they were doing. They made over 80,000 of these, so $4 or $5 times 80,000, that adds up quite a bit for a lot of money that can save. And I did read an article one time, and I really couldn't find it, some information on one cathode resistor, because a lot of the amplifiers, I think some of the ICO amps, Magnavox, they did it. But I read where when you have match pair with one cathode resistor, it does help keep the amplifier stable. But again, you have to use match pair. I was looking for that to see the reasoning in a testing that someone did, but I really couldn't find it. Looking at the power supply section, you can see some addition of some 0.1 microfarad capacitors in there for filtering out some of the high frequency noise and such. And I used 47 microfarads, and on the other larger capacitors, I had 220s. That's what I used. They worked fine because it's something I had, trying to save $1 here. And that's why I didn't buy Dave's board. You try to save a few bucks here and there when you're doing this stuff, and You know, I'm on a limited income, so everything costs, parts are expensive. So that's just the way I did it. And looking at his bias circuit in the diagram, and you can see, here's a close-up of what I did. I just laid it all out on the turret board and soldered everything on top, and it works well, and it mounted in there on top. And I ran out of board material. That was the last piece I had, or I would have made it a little bigger because I couldn't fit the common connection for testing the bias in there. There wasn't enough room for it. So I just soldered a wire into that connection there, and actually I clipped it right on top of the heat sink of the regulator. Worked out real nice. So the left channel, again, is the same as the right channel, all the enhancements there, and you can see the addition of also the 10 ohm resistors in parallel coming off of on Dave's bias circuit there that I put in there, and they're all actually on the board that I did there. These are the 4 resistors there. You can see them. But he says to take a average and adjust the control with an average between the 2 test points. If you can get an average of 27 millivolts, or 0.27, I'm sorry, not 27, that should be 270. You 0.27, you're doing good. And I could get that in these tubes. I think it was like 25 volts on one side and like 31 or 32 on the other side, whatever it is. It averaged out to 27. And so they're still working, they're still staying stable, so I'll use them for a while. You look down at the heater circuit changes, and you notice on the original, the heater circuits was V3, 5, 6, V, and V1, is it 5? Yeah. And the other one was 4, 7, and 3 and 2. But what Dave did was to even out the current draw, and also to drop the current on the driver tubes, which helped with a little bit of the hum on the driver circuit. So now we have V6 and V5 and V4 and V3 feeding one set of filaments there. And there's also the resistor there, which is a 1 ohm 3 watt resistor, and it is feeding V3 and V4 on the driver tubes. Let's slow that and drop the filament voltage down a little bit. And the LED I put in, it's just a bayonet AC/DC 6 volt LED bulb. Works nice. It's not going to burn out like the original bulbs do. So then you see V8, V7, V2, and V1 connected to the other transformer lead. So it worked out. The hum adjustments now, you have one hum adjustment is for the driver on the output driver hum, and the other adjustment is for the preamp hum, and it works pretty good with that type of typical setup. So again, here's the bottom. I ran a few, the wiring a little bit different than the original, added a few extra ground wires here and there, and so it worked out good. If you have one of these amps, by all means, go to Audio Karma and read everything that Dave suggests to do on these things. because you'll find it's a lot of fun, and it really sounds nice as it is. I probably won't make any other changes except some shielding on those preamp tubes, and maybe some little shielding around the power switch and such, which will help. So let's look at the switch here. Now the wafer switch, actually, I took it apart. As you can see, the wafer switch, they get pretty dirty, and they get that black corrosion on them. And what I did was I actually took the switch apart, and I have a full-size Dremel, but I also have a little cheap 12-volt Harbor Freight Dremel that works great with the little brass wire brush, and hooking it up to my variable bench power supply to slow it down. That and some deoxit, and it really cleaned these up real nice and didn't damage them. And give it a good coat of deoxit after to help that corrosion, that maybe it won't come back for a long time again. Probably not in my lifetime. But as you can see, the wafers, when I took it apart, you can see how nice they cleaned up compared to what the original wafers look like. And I can't think of anything else I wanted to show you and talk about. That I did have some of the outside sheathing on one of the output transformers kind of fell off. But the plastic inside was good. But I just put some heat shrink over it, those areas that were damaged. Normally I tear end bells off a transformer and I'll replace the wiring, but these look like when they dipped them, they were pretty sealed on there pretty good. So I did not want to mess around with that and damage them. And they, especially on the power transformer, I wouldn't want to have to buy any new transformers. But again, these boards, you said they were fully loaded, both the output boards that I purchased and the preamp board. They came from the board house like that, which made it nice. And they have those WIMA capacitors on there, which aren't too bad. And in this case, they're just as good or better than the original ones. So you could actually do these modifications with the original boards, but I just thought, hey, if I'm going to do it, I might as well just replace them. Because if you did do the modifications to use an adapter for the 6GH8A, and then somebody stuck a 7199 in there, it might not work properly. I don't know down the line, but this case, this way, everything's kosher and it will work out right. So if you have any questions, comments, I'm sure if you've messed around with these, you've seen all this and heard all this before. But have a good day. God bless and Merry Christmas.